Hello guys, so today I'll be showing you on how to use the destruction tools in Houdini. So we're gonna go about on breaking a wall with a sphere or a ball, and we're gonna see all the nodes and all the ways we can actually break the wall. If you don't have any knowledge of Houdini, be sure to look at my previous video which explains the very basics of Houdini. So it's quite helpful for the newcomers. So let's get started now. The first thing we're gonna do is create a geometry node. We're gonna dive right in and we can start by creating our wall. So I'm gonna put down a cube and let's use a transform node to scale it. So here I've put down a transform node. Let's view it, and now I can scale it in whichever direction I want. So I'm gonna make this a bit thinner and wider, and I'm gonna scale it in this direction. And since I want it to touch the grid, I'm gonna put this on half of my Y scale, which is 2.3, so it exactly fits on my grid. Now the next thing I'm gonna do is use my destruction tools. The name of this node is my Voronoi fracture node, so I'm gonna put that down. If I input this, nothing is gonna happen. Why? Because we need points for Voronoi cells. So to create points, we have to use a node called the scatter node. What this essentially does is scatters points around a geometry like this. So as you can see, it's scattering about 1000 points. We don't want so many. 100 is fine. And let's look at the Voronoi fracture. So these are all our pieces that have been built by the Voronoi fracture. So these are individually fractured, and we can put down an exploded view to view that. Here are all the individual pieces. Looks pretty good. I'm gonna delete that for now. Now the next thing I'm gonna do is use an assemble node. Now when we use Voronoi fracture, assembling the node is very important since we wanna create a packed geometry. So we're gonna click on create packed geometry, and if we see on our Voronoi node, we already have a name attribute already here. So we don't need to create one more. So let's uncheck this. And here you can see we have the name attribute and something known as packed fragments right here, which wasn't there earlier. So this is what our assemble node does. Now here we can put down a null node and we can call it out underscore gear. Now what a null node does is basically it's more like a reference which we will use in our DOP networks to call or reference this object. So it's basically, it makes it much more simpler and easier to find this node when we use larger workflows especially. So now let's create our DOP network. We can put down this node, and now our DOP network is where our simulation happens. We can double click and go right inside. So the first thing we're gonna do is create an RPD packed object, which is our wall, and a bullet solver, which is our solver for our destruction and our RPD, and we can put down a gravity node, and let's connect this. Now let's see what we get. Well, I'm gonna put this on and nothing is gonna happen. Since we haven't referenced our object, so we're gonna use our null node here and select our out geo. and accept it. Now you can see our wall is falling down. Well, we have two walls. That's a bug. So we're just gonna go right back in, and you can see we have only one wall here, and our wall is falling down because of our gravity node. So what we're gonna do is create a ground plane. So let's create a ground plane. Let's merge it inside our solver network, and we want the ground plane to be above. So we're gonna click, and we can drag it up or press the button. So we have a ground plane first. That is very important. And now you can see we have our wall falling down. Now why is it breaking? Because of our gravity force. If I disable it, nothing is gonna happen to our wall, as there is no force acting on our wall. Now we need to prevent that, since we don't want our wall breaking before the simulation. So what we're gonna do is create something known as a constraint network. To do that, the first node I'm gonna put down is connect adjacent pieces. So I'm gonna take the geometry node, and here we can see in our wireframe mode our constraint network. So we need to select adjacent pieces from surface points, and you can see our white line is our constraint network. This constraint network is what is holding all of our pieces together. It acts more like a glue, or whatever you could call it, something which is holding every piece together and making it a wall. Now this is fine, and now what we're gonna do is use an attribute wrangle. We will use this to create our constraint name and our constraint type. So s, which is a string, at the rate constraint name is equal to glue. You can put down anything here, and s at the rate constraint underscore type is equal to all, and we're gonna run this over primitives, as our Voronoi pieces are primitives. And now here we can put down a null node again, and we can call it out underscore con for our connectors. And now we can go back to our DOP network, and now to connect our constraints, we have to put down something known as our constraint network. So I can put that right here. Now it's gonna give me an error since we need our constraints. So we will create a glue constraint relationship, which is essentially our glue constraint. Now nothing is gonna happen. Once we do this, since our data name is Conrail glue, we need to change it to what we had kept it earlier. If you remember, we had kept it as glue, and here we have all our other values. So if I now play this, you can see our wall is gonna still fall down. That is mainly because we haven't referenced our constraint null object in our constraint network. So we have to go on a constraint network, and we have to choose out con. And now if I play this, our wall is gonna stay there together. You can see the red colors, which represent your active constraints, and the wall is not gonna fall. If I change my strength to say 0, the wall is gonna fall immediately. So we know that now our glue constraint is working. Now the next thing we're gonna do is create a ball which will collide and with the wall. So let's put down a sphere. Let's put down a transform node. Let's view that. Let's translate it up, and let's move it in our z direction, somewhere around here. Yep. and here I can put down a null, and let's call this out underscore sphere. Now we can go back to our DOP network and put down a node called RBD object. Let's connect it by merging it with our current RBD packed object. And now we can see the sphere. But we need to reference our null object which we create. So we will choose our out sphere, and we've got our sphere right here. And out here we have a few options. Create active geometry. And suppose you have an animation, like you animate your sphere from here to here, you need to click on use deforming geometry. Now we don't want to do that, so yeah, you can go down and see we have our velocity, and we're gonna put down a negative velocity, so it goes down in the negative z direction. Here you can see, whoa, we've got something really nice. Our wall is breaking down by our ball colliding. Let's increase our velocity and see what happens. Whoa. Now our wall is breaking fine, but I don't want the entire wall breaking as a result of the ball. And a sphere is just rolling down. We don't want that. So we can increase your density. It's more like a metal ball. And we can increase our rotational stiffness to about 40. So it does not rotate as much. So it's more like a hard metal bowling ball type of object. Now the next thing I want to do is, as I said, I do not want the entire wall flying out. Say the bottom of the wall is fixed to the ground. Well, how do I do something like that? Well, it's quite simple. Let's in our DOP network there is a variable called active which is used. So we're going to use that variable and edit it. So we can disable our active attribute on the pieces that are on the bottom. So I'm first going to use I, which is integer, @active is equal to 1. This is activating all the pieces or the points. The next thing I'm going to do is group the points which I don't want. So I can choose create bounding box, which we can find right here. Let's enable it, and we can change the size, and the pieces which are filled are the orange pieces, which we will disable soon. So we're creating a group called group 1, and we can alt and drag and select I@active as 0, and we can choose our group 1. So our group 1 points are disabled while our other points are enabled. If we now go into our DOP network, we can see that only our center of the wall is breaking, and it's acting really like a wall and not like a bunch of pieces. So that's pretty nice. If I also want the impact of the ball to be greater, I can go on my constraint or my glue constraint, and I can increase my propagation iteration. So if I want a huge blast, I can make it 50 and my entire wall breaks. I clearly don't want that, so I can reduce it. It's still too much, so let's reduce it further, and I'm just gonna keep it 2. Yep, this is fine. Now the next thing we can do is if we see our Voronoi fracture, our wall is evenly scattered. We don't want it like this, since our ball is affecting only this much area of our wall, while the rest of it just stays stagnant. We don't want so many pieces there. So there is a way to solve that. Now our scatter node is at the center of each point of each piece, and it's dividing our wall quite equally. So essentially we have to find a substitute to that and unevenly distribute our points towards the center. There is an easy way to do that. We can create an add node. Our add node creates a point. So here you can see we have 1 point at our origin. Now we can actually translate it and move it up. Now I have only 1 point. I need more points. So there's a node called point replicate. Let's put that. And here you can see we have many more points. We can further edit this. We can create more points. And we can add noise. I can also change my shape. So say I want it spread over a larger size, I can do that. So you can see that I need it somewhat like this, lessen the Z. Let's keep it few points down. I don't want too many. Yeah, this seems just about right. Or we can just keep it as 0, about 0.04 or something like that, minus, sorry. Now we can keep a few points on the right and on the left. So I can just click this Alt and Shift it to duplicate it. And what I'm gonna do is in my point replicate, I can shift the size. I can shift also the center, not my size but the center, and I can move it here, and I can reduce the quantity to about say 60. Yeah, that looks fine. And I can again duplicate it, and I can shift the center of our point to the other side, say somewhat about yeah, right here. Now we've got all our points. Let's increase our points to about say 100 on our sides, and at the center we can make it about to let's say 500. And now we can merge all of those nodes, and so it's basically a substitute for our scatter node, and we can put that into our fracture. And now you can see we've got a much more noisy and uneven distribution, which looks much better. And if I go in my DOP network, let's see what that gives us. Let's play it, and whoa, we have much more points, and our wall is breaking down from the start since our constraint network was disabled. And now we've got much more detail, and it's looking really nice now. Yeah, and it's looking much better than what we had. Now what we can do is go back. In our SOP level, we have to import our geometry in our SOP level from our DOP level. So what we have to do is create a node called the DOP import. We can drag our DOP net here, and in our object mask we use the name of the object we want to import. So here if you see we have our RBD packed object 1. We can copy that and place this here. Now we can either fetch geometry from DOP network, which will give us the geometry directly. As you can see, it's giving us our geometry. Houdini does that sometimes, where it shows the previous cache. So we have our entire simulation here, but I don't quite like this workflow. I prefer to use create points to represent objects. So what we have here is points, which are representing our fractured pieces. So what we can do after this is use transform by pieces, and we can put this down in the middle, and in our first input we can use our out geo, where I'm going to use our out geo. Now we'll get the same result as what we had. We in this way we are more hands-on, and we can edit anything we like. So for example, if I want to give more detailing in the interior of the pieces, it's looking quite simple now, and usually in destruction it's not so simple, is it? So what we can do is use a node called the RBD interior detail right here. So this node was introduced in the newer versions of Houdini. So what we can do is now we will get an error that inside is not a valid group, since once we assemble our nodes it goes away. So either we can unpack it or use our Voronoi fractured node and hook that in. So here you can see we've already got much more detail. So I can reduce the detail size to say 0.05, and now you can see we're getting much more detail. We can increase our noise amplitude to about 0.3, and we can change the frequency and a few other settings you can play around with here. So it's looking really nice now, like a proper destruction sequence. Let's play it, and now we don't have a sphere here. To get that, we can again use our DOP import, and instead of our RBD packed object, we'll just put RBD object. This is what the name of our RBD object is, RBD object 1. So this will get our sphere. You can see we need to put fed geometry, and you can see our sphere right here, and we can use a merge node and put that in. So we've got our original simulation with much more interior detailing, and boom, we've got some nice destruction in this wall with nice detailing here now. So as you can see, if we want our wall to be even more, we can increase our propagation iteration to increase the blast radius. So this was the destruction way by using Voronoi fracture, and in the next tutorial we will see how we can use our RBD SOP nodes, like the RBD bullet solver. For example, we went here in the DOP network. We don't necessarily have to do that. So in the newer versions, Houdini has introduced SOP level nodes, where we can use those nodes to destruct everything in the SOP level. So we can go down on our RBD material fracture node to as a substitute to our Voronoi fracture node. But personally, I prefer this method, which I showed you now, since we have much more control over our simulation, and it's much faster than our SOP level nodes, which is much more CPU intensive. As you can see, the RBD interior detail node also took a lot of time to simulate, but it's good to have the knowledge of both the workflows, since here, as you can see, we've used RBD interior detail, which is part of those set of tools. Now we can merge and mix those tools out here, so it's quite helpful to know what those tools really do. So I'll see you in the next video. Hope you had a great time in this video, and if you learned something of value, do share this video, leave a like, comment, and subscribe for our newest videos. And goodbye for now.